aside from the 30, 60, 90 special right triangle, we should also know about the 45, 45, 90, as that one also finds its way into a lot of our problems. So the 45, 45, 90 is an isosceles right triangle. We know that by the converse of the base angle theorem, or the converse of the isosceles triangle theorem. So if we have a 45, 45, 90, we know by the converse of the isosceles triangle theorem that this thing is isosceles. So let's just call that one x and x. Now our goal is to find out what this hypotenuse is in terms of x. So we'll start by calling it y, but we know that by the Pythagorean theorem, x squared plus x squared is equal to y squared. We're just going to get y by itself. X squared plus x squared is 2x squared, and this is equal to y squared. So now we take the square root of both sides, and here we have that y is equal to root 2 times x. And so we know that this length, if the two legs have length x, then this one has the length x times root 2. So this is the proof of that relationship. Now let's do a few examples. Easy examples going from the leg to the hypotenuse, for instance. Well, the base case, if I call this leg 1 and this leg 1, then this is 1 times root 2, or just root 2. So there's the base case. That's the easiest case for me to think about. But what if you have something like 3? Well, then this one is 3 as well, since it's isosceles, and then this one is just 3 times the square root of 2. So that doesn't pose too big of an issue for students. It starts to get confusing when you don't have a root 2 in the hypotenuse length, or if these are given in some irrational form. But let's say this one is root 6. So let's just think about the base case. 1, 1, square root of 2. And these are similar. So we know that to get from the hypotenuse to a leg, we can just divide by root 2. So we just take root 6 and divide it by root 2 to get here. So we take root 6 divided by root 2. Multiply top and bottom by root 2 to rationalize the denominator here. And so on the top we have root 12, and this is divided by 2. Now root 12, that can be simplified since this has a perfect square factor of 4. This is the square root of 4 times 3, which is 2 root 3 over 2, which is just root 3. So the legs have length root 3. Yep. How about one more? What if a leg has a length like 3 root 6, for instance? Well, then this is also 3 root 6 because it's isosceles, and then this one here is 3 root 6 times root 2, right? Which is exactly 3 roots of 12. But we know that this is 3 roots of 4 times 3. 4 is a perfect square factor of 12. This is 3 times 2 times root 3. This is 6 roots of 3. So if you have a 45, 45, 90 with a leg of length 3 root 6, then the hypotenuse has length 6 root 3. It's kind of fun. Okay, so I hope this helped.